Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. Today, our we are going to start class 10th, subject physics, chapter 11, as we were doing before. As we have finished this chapter number 11, we have finished. Topic of today's lecture: problem we have discussed. Going to solve problem 11.1, 11.2, 11.3, and 11.4. Which are these problems are on page number 35. Again, class 10, subject physics, chapter number 11. We are discussing today problems 11.1, 11.2, 11.3, and 11.4. Today's lecture, we will discuss these four problems. With these problems are on page number 35. As in our earlier lecture, we have already solved the MCQs. And moving towards the problem. This is the chapter we are doing now, unit 11. As we have finished this chapter, now we are doing problem. Problem 11.1, which is on page number 35. If you open 10th class physics book, page number 35, you will find these problems. So I am reading the statement of the problem 11.1 first for you. 11.1. A normal conversation involves sound intensity of about 3 into 10 raised to the power minus 6 watt per square meter. What is the decibel level for the intensity? What is the intensity of the sound for 100 dB? In this numericals, we are required to find two things. One is what is the decibel level for the intensity of sound, and the intensity of sound when we want to find out the intensity of sound when sound is 100 dB, right? So I write the given data first. So given data intensity of sound is denoted with capital I, and this is given to me 3 into 10 to the power minus 6 watt per square meter. And you know the unit of intensity of sound is watt per square meter. And threshold intensity I naught is noted with I naught. As when we discussed this topic, I told you this is the reference level I will take all the time 10 is to the power the faintest sound, that is 10 is to the power minus 12. I told you this is the reference level of the intensity of sound. The reference level is sometimes called threshold intensity, and it is noted with I naught. I naught with 10 is to the power threshold intensity or reference frequency or faintest sound intensity level is 10 to the power minus 12 watt per square meter. This is given to me. What I am required, decibel level of intensity. This is we need to find out an intensity of sound at 100 dB. These two things are required in this numerical. Level of intensity in decibel. Decibel, I told you, this is the smallest unit of intensity of sound is decibel. So this is noted with L minus L naught. So recall your lecture when we recall the lecture, same lecture as we discussed. In level of intensity is noted with L minus L naught. Intensity of sound at 100 dB is noted with capital I, question mark. These two things are required. So I move towards my solution. So recall the formula L minus L naught 10 log I over I naught, which is dB. L minus L naught, L minus L naught. You can find this formula if you open page number 25. Under equation 11.5, you can find this formula 10 log I over I naught dB. So intensity level is denoted with L minus L naught. So he has written on page number, if you open page number 25 and equation 11.5, you will see intensity level is equals to 10 log I over I naught dB. So I'm using this formula. So in the couple of numerical, I will use the same formula. So you should know this formula, where it is coming from and on which page this formula is lying. Okay. So L minus L naught, I'm just putting the values. Remember, there are the two logs. One is log and one is ln. So on the calculator, you will find log log and ln log. So the difference between these two logs is this log has the base 10, but ln log is the base e. So you should, when you use the calculator, make sure you use log log, okay, not ln log. So you will use log log. So I'm just putting the values now. 10 log I value is 3 into 10 raised to the power minus 6. I'm putting the value 3 into 10 to the power minus 6. And I naught is threshold intensity is 10 to the power minus 12. I have just put these values in this formula. I is 3 into 10 to the power minus 6 and I naught is 10 to the power minus 12 watt per square meter. Now I substitute these two values. I am going to take this one on the top. So if this stands for minus 12, we should go on the top. This will be plus 12. So 3 multiplied by 10 to the power minus 6 multiplied by 10 to the power 12. Okay. Decibel is the unit of intensity of sound. Okay. So 12 minus 6, if bases are same, power will be added. Then 12 minus 6 will be plus 6. So if you recall the properties you have already studied in the mathematics class, when you will use the property of log, when there is a multiplication in the log, right? So you will change this into addition sign. Remember this the property, I'm using the property over here, log property over here. When there is a multiply sign, 3 multiplied by 10 power, there is a and log 3 multiplied by 10, then you can write log 3 plus, you can multiply sign will change into the plus sign. This is the property of the log, and log 10 to the power 6. Again, so this power, this is, I'm again using the property. If the power will become here, this is also the property 6 10 log 10. You can write like this. So if you with the help of calculator, if you take the log 3, you will get 0.427 on your calculator. If you use log log, remember guys, use log log, not ln log. Okay, log, if you take log 3, you will get 0.477. Okay, for 0.477. And log 10, if you take on your calculator log 10, it will come 1. So 1 multiplied by 6 is 6. So add them up, 0.477 plus 6, you will get 6.477. And then multiply this with 10, you will get 64.77 decibel. So intensity level, so we have solved our first part of the numerical. Decibel level of intensity is L minus L naught, which is L minus L naught is 64.77 dB. Now this is the second part of this, the same numerical 11.1. So as we have find L minus L naught intensity level of sound, which is 64 point, which is 64.8 dB. So I'm using the second part in which he is asked what is the intensity of the sound for 100 dB. Okay, I will use the same formula L minus L naught 10 log I over I naught. I will use the same formula. Now in this case, I will put L minus L naught as 100. Then I will put 10 log I, we need to find out. And you know the threshold frequency is 10 to the power minus 10 to the power minus 12. Uh, Students, please wait for a moment. I'm coming back. Sorry students, I am back now. So I will use the same formula L minus L naught 10 log I over I naught, which I used in my early part. So in this case, L minus L naught is 100 dB. 100 dB, so I put the values 10 log I, and the threshold frequency is 10 to the power minus 12. So again, you take this 10 to the power minus 12 on the top, it will be 10 to the power plus 12. So this 10 is multiply here. If it is go on the other side, it will be divided. So 100 divided by 10 is 10. So you use again the same property log I plus 10 log, you will use log 10 is power 12. So log I plus 12 log 10. So you use the same property of the log as we discussed in the last part of the same numerical. So 12 will come before that log, so 12 log 10. So you know log 10 is, if you take log 10 on the calculator, you will get 1. So 12 multiplied by 1 is 12. So log I will be same as it is. So 100 divided by 10, if 0 will be cancelled with this 0, so 10 will be left over here. So what I'm going to do, 10 minus 12. 10 plus 12, if goes on the other side of the equation, it will be 10 minus 12. So 10 minus 12 will equals to minus 2. Log I is equal to minus 2, taking anti-log on both sides. Why? Because I want to find only I, not log. Therefore, in order to cancel log, I will take the anti-log on both sides. So you will take, if you do on one side, if you take anti-log on one side, then you will have to take anti-log on both sides, because if there is an equation, so you take on both sides. So anti-log, you will take anti-log on this side and anti-log on this side. So this log will be cancelled with anti-log. This anti-log will be cancelled with this log. So I will be left. So if you, with the help of calculator, if you press shift, then log, then you will get anti-log of minus 2. So your answer will be anti-log of minus 2 will be 0.01. So if you take, if you this point, move this point on this side, so how many points you are moving? 1, 2, and the power will be 10 to the power minus 2 watt per square meter. So this is I found intensity of sound for 100 dB. So I is equal to 10 to the power minus 12 watt per square meter. So my result will be, in the first part I did L minus L naught, which is 64.77 dB, and I, in this part I found I, which is the intensity of sound 400 dB. So I is equal to 10 to the power minus 2 watt per square meter. So this is the end of the numerical 11.1. Now I'm moving towards 11.2 numerical. Again, students, I read the statement for this numerical. First, this numerical is again on page number. You can find this numerical on page number 35 of your 10th class physics book. So, the statement of the numerical is, if at Anarkali Bazar Lahore intensity level of sound is 80 dB, what will be the intensity of sound there? I repeat, if at Anarkali Bazar Lahore intensity level of sound is 80 dB, we are given intensity level of sound in Anarkali Bazar is 80 dB. What will be the intensity of sound here? Where, what will be the intensity over there? So I will use the given data. Sound level is noted with, in the last numerical we discussed, sound level is L minus L naught, noted with L minus L naught, which is 80 dB, and threshold intensity I told you already. I will take as a reference I naught is equal to 10 to the power minus 12, as we discussed in the last numerical as well. The threshold frequency or reference frequency is 10 to the power minus 12 watt per square meter. In this numerical, we are required to find intensity of sound. Intensity of sound is noted with I. Okay, I will use the same formula which we used in the 11.1 numerical. L minus L naught is equal to 10 log I over I naught in dB. So I will put the values L minus L naught is equal to 80. I will put 80 over here, and 10 log I, and I naught value is 10 to the power minus 12. Again, This 10 is multiply here. If it is go this side, this will be divided. So this 0 will be cancelled with this 0. So 8 will be left. Again here, I will move this 10 from minus 12 on the top. It will be plus 12. Okay. So when I will use the same log property over here, if there is a multiply sign here, log will change into plus sign. So log I plus log 10 raised to the power 12. Again, I'm using the property of log. If there is a power in the log, then it will come before the log. So 12 log 10. So you know log 10, value of log 10 is 1. So 12 multiplied by 1 is 12. So log I 8 is equal to log I plus 12. This plus 12, if goes on this side, so it will be 8 minus 12. 8 minus 12 log I. So log I will be 12 minus 8 is minus 4. Again, you want to separate out I, that's why you will take anti-log on both sides. Anti-log on both sides, so I will be anti-log of anti-log, this anti-log will be cancelled with this log, so I will be left. So if you take anti-log of minus 4, you will get 10 raised to the power minus 4 watt per square meter. So intensity you found I tends to power minus 4 watt per square meter. I repeat this numerical numerical 11.2. If at Anarkali Bazaar, Lahore, intensity level of sound is 80 dB, what will be the intensity of sound there? So given data, intensity level is given, sound level intensity L minus L naught 80, 80 dB is given to me. Then we'll use threshold intensity I naught for their reference frequency I naught, which is faintest sound, tends for minus 12 watt per square meter. In this numerical, we are required to find required intensity of sound is noted with capital I. So you will use the formula which we used in 11.1 numerical as well. The formula is L minus L naught 10 log I over I naught. This formula you can find on page number. I'll show you now. You can find this this formula on page number 25 of your 10th class textbook under equation 11.5. Intensity level is equal to 10 log I over I naught. You can verify this formula on 125 page of your 10th class textbook. So L minus L naught 10 log I over I naught. I just put the values. 10 log I, you know I naught is 10 to the power minus 12. So you will take 10 to the power minus 12. If this goes on the top, it will be plus 12. So I multiply by 10 to the power 12. Again, 10 is multiply here. If it will go on the other side of the equation, it will be divided. So 80 divided by 10 is 8. So I will use the property of the log here. If there is a multiply sign here in the log, then this will convert into the plus sign. So I will write log I plus log 10 to the power 12. Again, I am going to use the property of the log again. If there is a power of the 10 in the log, then it will come before the log. 12 log 10. So log 10, if you take on the calculator, log 10 will be 1. So 1 multiplied by 12 is 12. So log I plus 12 is equal to 8. If you take 12 on this side, 8 minus 12, you will get minus 4. So log I minus 4. Again, you will take anti-log on both sides. So anti-log, left hand side anti-log will be cancelled with this log. So I will be left. So if you take anti-log of minus 4, you will get 10 raised to the power minus 4 watt per square meter. So we have found intensity of sound 10 to the power minus 4 watt per square meter. This is the end of the numerical 11.2, which was on page number 35. Now I'm heading towards 11 problem 11.3. I read the numerical statement for you first. At a particular temperature, the speed of sound in air is 330 meter per second. If the wavelength of a note is 5 centimeter, calculate the frequency. Calculate the frequency of the sound wave. Is this frequency is the audible range of the human ears? Again, I repeat this numerical statement first. At a particular temperature, the speed of sound in air is 330 meters per second. If the wavelength of the note is 5 centimeter, calculate the frequency of sound waves. We need to find out frequency of the sound wave. And the second thing we need to find out is the frequency in the audible range of the human ears. And as when we discussed audible, what is audible frequency range, I told you the human ears audible range is 20 hertz to 20,000 hertz. So we will check this as well. So, given that I will write, the speed of sound in air is noted with v, and it is given to me 330 meter per second. And unit of velocity is meter per second. Unit of speed is meter per second. Wavelength is noted with lambda, and this is given to me 5 centimeters. Since it is the length and the SI unit of length is meter, so I convert this into centimeter into meter by dividing this with 100. So 5 divided by 100 is 0.05 meter. So we have converted wavelength into meter, which is the SI unit of the length. So speed of the sound in air is given to me 330 meter per second, and wavelength is denoted with lambda, so which is 5 centimeter. So 5 divided by 100 is 0.05 meter. In this numerical, we need to find out frequency, and frequency is denoted with small f question mark. And we have already discussed this formula in our previous chapter number 10, previous chapter 10. So V is equal to F lambda. Just separate out F because we want to find out F frequency. So separate out F. So V divided by lambda. Just plug in the values. V is 330 and lambda is 0.05. Just put the values. You will get 6600 hertz. And the unit of frequency is hertz. You know this, the unit of frequency is hertz. So in order to convert this into scientific notation, I will move my point is after 0. And since I'm moving from right to left, 1, 2, and 3, how many digits I am moving? 3 digits, so 6.6 into 10 power 3 hertz will be my required result. So frequency is 6.6 into 10 power 3. So guys, that when we need to check whether this is in audible frequency range. This 6600 comes in the audible range. So our audible frequency range is 20 hertz. Human ears is 20 ears to 20,000 hertz. So 6600 comes between 20 hertz to 20,000 hertz. So we will say yes, this range lies between the audible frequency range. This range 6600 lies between the audible frequency range. So our answer will be yes. So frequency, this is we need to find out frequency is 6.6 into 10 power 3 hertz, and this frequency lies between the audible frequency range, and our audible frequency range for human ears is 20 hertz to 20,000 hertz. So 6600 comes between these two numbers, 20 hertz to 20,000 hertz or 20 kilohertz. So this comes in the range of audible. So we say yes, this range lies between the audible frequency range. I repeat this numerical. At a particular temperature, the speed of sound in air is 330 meters per second. If the wavelength of a node is 5 centimeters, calculate the frequency of sound wave. Is this frequency in the audible range of human ear? So speed of sound in air is noted with V, with V is given to me 330 meters per second. Wavelength is denoted with lambda, which is 5 centimeters. So I need to convert this into meter because the SI unit of length is meter. So lambda is the wavelength length. So its unit is SI unit is meter. So I will convert this centi into 100. So 5 centi is 100. So I will divide this 5 divided by 100. If you convert this into this point will be removed. So 0.05 meter. It has converted into meter. The SI unit of length wavelength is meter. So that's why I converted centimeter into meter. Again, frequency we need to find out. F we need to find out. I use this formula V is equal to F lambda. In my previous chapter, when we discussed chapter number 10, we read this formula V is equal to F lambda. Since I want to find out frequency, so I will separate out F. So V divided by lambda. So just plug in the values. Value of V is 330. 3 divided 30 and lambda is 0.05. So 330 divided by 0.05, you will get 6600. So how will you convert? You convert this into scientific notation. So 1, 2, 3, how many digits you are moving from right to left? You are moving 3 digits from right to left. So the power will be positive, times power 3, 6.6 into 10 power 3, and the unit of frequency is hertz. Since 6600 lies between 20 hertz and 20,000 hertz, which is the audible frequency range for human ears, so 6600, yes, this range lies between 6600 range lies between the audible frequency range. So this is the end of the problem 11.3. Now I move towards my next problem 11.4. This 11.4 again on page number 35 of your 10th class textbook. I read the numerical statement first. A doctor counts 72 heartbeats in 1 minute. Calculate the frequency and the period of the heartbeat. So I repeat, a doctor counts 72 heartbeats in 1 minute. Calculate the frequency and the period of the heartbeat. So this is given to me. Number of heartbeats is noted with small n, which is 72 given to me, and time is 1 minute. Time is denoted with small t, that is 1 minute, and you need to, and SI unit of time is second. So that's when in 1 minute you have 60 seconds. So number of heartbeats is noted with n small n, which is 72, and time is 1 minute is given to me. So 1 minute is equal to 60 seconds. So in this numerical, we need to find out frequency, and frequency is denoted with small f, and the time period is denoted with capital T. So question mark. So this is the time period. Time period is denoted with capital T, and the frequency is denoted with small f. So I will use the formula solution. F is equal to number of heartbeats divided by time in seconds. So F equals to N by T. I will use this formula. N is 72 and time is 60. N is 72 and time is 60. So 72 divided by 60, you will get 1.2 hertz, which is the unit of frequency. Unit of frequency is hertz. As the unit of frequency is hertz. So what I did, I used this formula F is equal to N by T. N is the number of heartbeats, which is 72. So time is 60. So 72 divided by 60 is 1.2 hertz. So our time period, you know the relation between time period and frequency. So there is an inverse relation exists between time period and frequency. We have discussed this formula in our previous chapter number 10. Time period is equal to 1 over f. So there is an inverse relation between time period and frequency. If we have more frequency, time period will be less. If we have less frequency, time period will be more. So inversely proportional means if one thing increase, other will decrease. If one thing decrease, other will increase. So I am just putting the values of frequency which we just found. So frequency I just found 1.2. So 1 divided by frequency is 1.2. You will get 0.833 second. So time unit of time period is second. So our required result is frequency f is equal to 1.2 hertz. This is frequency is 1.2 hertz and time period is 0.833 seconds. So students, in this numerical, we found frequency and the time period, and we use two formulas. One f is equal to n by t, and the other formula is time period is equal to 1 over f. So I just use these two formulas to find time period and frequency. Our frequency is found to be 1.2 hertz and time period is 0.833 seconds. This is the end of the problem 11.4. So we have done our four problems 11.1, 11.2, 11.3, and 11.4. These all problems are on page number 35 of your 10th class textbook. So I hope, guys, you understand this numericals. If you have any question regarding these four numericals, please feel free to ask me questions. I'm here to answer your questions. If you don't understand any part of the question, you can feel free to ask questions. Before moving towards the question, I will show you your homework. Practice the numericals problems two times on rough registers and transfer one time on neat registers. So students, the numericals which we did today from 11.1 to 11.4, you need to practice them two times on your rough registers. And once you practice them on rough registers two times, then transfer them on neat registers as we usually do this. So I hope you understand the, the topic or the problems, today's problems, and you understand the homework. If you have any questions, please feel free to ask us.